All right, everybody, welcome to your 5th video lecture. This one is over integration methods. Okay, so in the first semester and even in the first part of this summer assignment, we've mostly talked about derivatives. Well, integration and anti-differentiation is just going backwards from the derivative. Okay, so to find a function whose derivative is, for instance, 2x, you might use your knowledge of derivatives to conclude that the antiderivative is x squared, because you know the derivative of x squared is in fact 2x. Okay, so that leads into the definition of an antiderivative, which you can see clearly right there. Now, if you're going to continue this discussion about 2x, you might recognize that there is more than one antiderivative of 2x, and I've listed a couple of examples here. You might have f1 of x just be x squared. The derivative of that, of course, would be 2x. You might have this function, f sub 2 of x squared minus 8. The derivative of that is also 2x, since the derivative of negative 8 is just 0. And then you might have x squared minus or plus some other constant. Okay, so the way that we kind of deal with this is by using what's called a constant of integration, and so that's what you can kind of see right here, that we're going to add on to any what is called an indefinite integral. So we'll talk about definite integrals in a later lecture, but this lecture will be all about indefinite integration. Okay, so here are the basic derivative or integration rules that you should have memorized. The differentiation formulas are all here on the left, and then the integration formula is here on the right. So the idea is an integral is just going backwards from the derivative. So just for example, you might look, for instance, at this one. Okay, the derivative of sine is cosine, which means that the antiderivative of cosine x dx is sine x and then plus some constant c. Please make sure that you don't forget about this plus c whenever you're taking an indefinite integral. Okay, so make sure that you have all of those memorized. If you have the derivative rules memorized, then it shouldn't be real hard to get the integration rules memorized as well. Now, the reason I'm scrolling back up here is because I want to alert your attention to one of the most important antiderivative rules, and this is really the one that you focused on the most in your pre-calc class, and that's the power rule. Okay, so remember, to take the derivative of a power, you're going to move the exponent into the front and then subtract 1 from the exponent. In order to take the antiderivative of a power, you're going to increase the exponent by 1 and then divide by the new exponent. So that's the power rule for integration. Okay, so let's go down here and see if we can utilize the power rule. So the first problem in example 1 says the integral of 3x dx. Okay, well, I know that the exponent on that x is a 1. Even though it's not there, it's an understood 1. And so if I'm going to use the power rule here, I'm going to increase that exponent by 1 and then divide by the new exponent. Now, if the constants could be simplified at all, I would go ahead and do that, but in this case, 3 over 2 is already simplified, and so all I really need to do is add my plus c so that I get the final answer. Okay, in example B, we have the integral of 1 over x cubed dx. Now, very similar to derivatives, if that x is in the denominator, I have to rewrite it using algebra in order to be able to use the power rule. So since that x cubed is in the denominator, I'm going to rewrite it as the integral of x to the negative 3 dx. Okay, once I do that, now I'm able to use the power rule. So I increase the exponent by 1. If I increase negative 3 by 1, it becomes a negative 2. And then I'm going to divide by the new exponent, which is negative 2. And then don't forget my plus c. So the way that I would probably write this is negative 1 over x squared plus c. So just moving the x to the negative 2 to the denominator, and then that leaves just a 1 in the numerator, and then I can't forget about my 2, that is right here. So negative 1 over 2x squared. And the nice thing about these problems is that you can take the derivative to check your answer. So like, for instance, over here, if this was, let's say, y, then y prime would be equal to 3 halves times 2x and so that would be 3x, which is what we started with back up here. Okay, example C, we have the integral of the square root of x. In order to be able to use the power rule, I'm going to rewrite that as x to the 1/2 power. Okay, so just remember from algebra that the square root of x means x to the 1/2. Okay, so using the power rule, we're going to increase 1/2 by 1, so that is going to give us 3/2, and then divide by the new exponent, which is 3/2, plus c. But anytime I divide by a fraction, that's really multiplying by the reciprocal. So this is going to be 2/3 x to the 3/2, and then don't forget plus c. Okay, example D, we have 2 sine of x. Now what I'm able to do with that constant, as we're going to find out in the next lecture, is I can move that constant into the front of the integral sign. I can't do that with any variables, but I can definitely do it with constants. Okay, so if I look back at my rules, the antiderivative of sine of x is negative cosine of x. And so our answer here is going to be negative 2 cosine of x plus c. Okay, in example E, we have the integral of 3 over x dx. So this is going to be rewritten as the integral of 3x to the minus 1 dx so that I can actually try to use the power rule. Now the reason I said try and not actually use the power rule is because notice if I increase the exponent by 1, what does it become? It becomes a 0. Well then the next step would be to divide by the new exponent, which would be dividing by 0. I cannot do that. And so what I want you to recognize back over here on this page is that for this rule, the natural log rule down here at the bottom, this can also be written as the integral of x to the negative 1 dx. And so anytime you see that raised to the negative 1, you're going to think that's the natural log rule. Okay, so the antiderivative here is going to be 3 natural log of the absolute value of x plus c. Okay, example F, we have the integral of just dx. Well, another way to think about that is just the integral of 1 dx. And so if you think, okay, well, what is a function whose derivative is equal to 1? That, of course, would just be x. So the answer here would just be x plus c. Okay, so don't get confused by that one. It's not meant to be confusing. We just need to do one like that so that you can see how to handle that. Okay, G and H are integrals of a sum or a product. This is really not any different than what we've done in the first couple of examples. We're just going to take the antiderivative one term at a time. Okay, so for example G, we have the integral of x first, and so that's going to be x to the second power divided by 2. So increase the exponent by 1 and divide by the new exponent. And then the antiderivative of 2 is just 2x plus c. Now if you wanted to rewrite that as 1/2 x squared plus 2x plus c, certainly that would be perfectly fine. If you wanted to leave it like this, that would also be perfectly fine. It's really just about what does the answer choice look like that you're trying to find. Okay, and then example H, very similar to example G, so we're going to increase the exponent by 1. That's going to become a 5, and then divide by the new exponent, minus 5x cubed over 3 plus 1/2 x squared plus c. Okay, so again, just an application of the power rule, increasing the exponent by 1 and then dividing by the new exponent. Okay, in example I, we have a fraction. And so whenever we have a fraction with x's in the numerator and denominator, we're going to have to split through the numerator in order to be able to find that antiderivative. So this is going to become the integral of x over square root of x, but instead of square root of x, I'm going to write that as x to the 1/2 plus 1 over x to the 1/2. Okay, so just splitting through the numerator there so that I can set up using the power rule. Okay, well still without using the power rule, we're going to simplify. So x over x to the 1/2 is x to the 1/2 plus 1 over x to the 1/2 is x to the negative 1/2 dx. Okay, now I have done enough algebra in order for me to be able to use the power rule. So I bump up the exponent by 1, that's going to say x to the 3/2, and then divided by 3/2 is the same thing as times 2/3. And then plus, if I bump up negative 1/2 by 1, that's going to become positive 1/2. Dividing by 1/2 is the same thing as multiplying by 2. And then don't forget plus c. Okay, very similar in J, so we're going to move that square root of x up to the numerator. It's going to become 2x to the negative 1/2 dx. And then increase the exponent by 1. That's going to become an x to the positive 1/2, and then divided by 1/2 is times 2, plus c, which is going to give me 4 square root of x plus c. Okay, it would have been okay to leave it to the 1/2 power, but again, I want you to kind of see the different ways that the answer can be written, because you never know what the answer choices might look like. Okay, in K, we have the integral of t squared plus 1, but then all squared dt. What we have to do in this case is go ahead and square out the t squared plus 1. Okay, so if we think about this as being t squared plus 1 multiplied by t squared plus 1 dt, then that means that this is going to equal the integral of t to the 4th plus, we have 1t squared here and another t squared there, so that's a total of 2t squared, and then 1 times 1 is going to give me 1. Okay, so I have to multiply all of that out so that I can now use the power rule. So if I use the power rule, this is going to say 1/5 t to the 5th plus 2/3 t cubed plus t plus c. Okay, example L is very similar to example I, and so I'm going to again split through the numerator so that I have x cubed over x squared plus 3 over x squared dx. Okay, and then simplifying that into a format that I need in order to use the power rule, we're going to have the integral of x plus 3x to the negative 2 dx. And now I am able to use the power rule. So the antiderivative of x is just 1/2 x squared, and then the antiderivative of 3x to the negative 2 is going to be x to the negative 1. Don't forget about the 3 that's here. And then divided by negative 1 is just going to change that into a minus sign in between those terms. And then plus c, which of course could be rewritten if you wanted to as 1/2 x squared minus 3 over x plus c. Now again, I'm not going to get too caught up in how you write the final answer because it's all going to depend on what the answer choices look like. But you need to be able to recognize that certain things mean the same thing. So what I mean by that is you need to be able to recognize 3x to the negative 1 and 3 over x are really saying the same thing, just in a different form. Okay, examples M and N. So in example M, we're going to have to distribute that cube root of x before we get going, because we cannot take the integral of a product. We'll actually learn in BC how to take the integral of a product, but that is not this type of a problem. So the first thing I'm going to do is I'm going to distribute the x to the 1/3 power. So I know I can think of this as being x to the 1/3. When I distribute that x to the 1/3 with that x to the first, I'm going to add their exponents. And so if I add 1/3 and 1, I'm going to get 4/3. And then minus 4x to the 1/3 dx. Now I'm ready to use the power rule, so this is going to be x to the 4/3 plus 1 is really 7/3, divided by 7/3 is the same thing as times 3 over 7. Okay, minus 4, and then x to the 1/3 plus 1, well, that's going to end up being 4/3, and then divided by 4/3 is the same thing as times 3 over 4 plus c. And so if I were to clean up that middle term, my final answer is going to be 3/7 x to the 7/3 minus 3 x to the 4/3 plus c. Okay, example N, we have the cosine of 3x. Well, if I look back at my rules, I know the antiderivative of cosine is sine. So that would lead me to believe that the antiderivative here is sine of 3x plus c. Okay, so I'm going to leave that there for just a minute and conjecture that that's the answer, and then I'm going to show you why it's not the answer. Okay, so here's why it is not the answer. If you were to retake the derivative of that answer that I'm saying is not the answer, then here's what you would get. The derivative of sine of 3x is really equal to 3 cosine of 3x. But we don't have a 3 in the original problem. It's not there. So what we're going to do is we're going to kind of just put it in there, okay, like this. So I'm just rewriting the original problem, the integral of 3 cosine 3x. But in order to do that, I've got to make sure I don't change the problem. So if I multiply by 3, I've got to also divide by 3 or multiply by 1/3. And so now the antiderivative of this piece is this, and because of this 1/3 that's in the front, we've got to have a 1/3 in front of our answer. Okay, so our final answer altogether is going to be 1/3 the sine of 3x plus c. And now if you were to take the derivative of this, you would get back what we originally started with. So you've got to be very careful to pay attention. Is there a constant there that you need to kind of account for?